Hey everyone and welcome back to my YouTube channel. So in this tutorial we are trying to discuss about autoencoder, and we also see how can we reconstruct an image from an input images. So if you are new in my YouTube channel, so please do subscribe my channel and must hit the bell icon, because in every week and daily basis I build some videos regarding machine learning, data science, artificial intelligence and so on. So you can see here I uploaded more than 100 video in my YouTube channel, so please check it out, all the videos if possible. So let's get started. So first I would like to discuss about the autoencoder technique, how it actually works, then I'll go on the code. So the first question is, what is actually autoencoder? So you can see here diagram here. So first it will take an input, then it will go to the encoder and the bottleneck or code and decoder and explain. So what is actually do? You can see here an images and this one images. So this images is the input images, and this one is the reconstructed input, or you can say reconstructed output images. So you can see here this one is the output images. So in this tutorial we are discussing about that. So that's mean when you give input images to the autoencoder, so it will encode the image, then finally it will decode the same images. Okay, so this time x, that's mean independent and dependent variable are both are the same. Okay, so this is the actual technique of the autoencoder. That's when you give an input and the model will train these images and give you output the same images. So using this autoencoder you can build so many applications like image noising and image colorizations and anomaly detections. So you can see here this is the example for the noisy import to denoising the images. So if you give your noisy import images, and it will go to the encoder, and you can see here the feature we want to extract from the images and the compress representation and again decode that, and it will denoising the images. So in this tutorial we are discussing about how can you reconstruct an images from the input images. All the code are already done by me. So autoencoder implementation using Tensorflow, Keras and Python. So the image we are going to use Mona Lisa. So this is the images. So this is the image for the Mona Lisa. So using this Mona Lisa images we are going to reconstruct this image back. So I'm going to close that. So first thing first, we need to import numpy as np. So import numpy as np. Then we import from Keras. From Keras.preprocessing.image we are going to import image to array. Then from Keras.layers we are going to import dance layer, the converter and the max pooling layer and the upsampling. Why upsampling? Why? Because we do the decoding part. So convert, dance, max pooling, this will help us to do the artificial neural network work. Okay, and upsampling 2D would actually help us to decode the images. That's mean reconstruct these images. So from Keras.model we are going to import the sequential model, because we are going to use the sequential model in this case. So we are going to import CB2 because we deal with the images, so that's why I'm going to use CB2. That's in OpenCv. And I'm going to import matplotlib as pyplot. Okay, you can see here to show the images as a pyplot, and I put here a random sheet np.random sheet equal 40. Okay, so image size we put here 256. So you can use up to you, it's up to you. So I'm most comfortable to 256. Okay, so then I initialize empty array, image data equal to empty array, and I read the Mona Lisa images, Mona Lisa.jpg images. So this was the Mona Lisa image, I'm reading this. Then after that we need to convert this image into RGB. Why? Because OpenCv read the image in the Bezier format. Okay, blue, green and red. So now we need to convert this image into red, green and blue. Okay, you can see here. Then we can resize our images. Okay, after resizing our images we need to convert this image into an array. So that's why I'm using this image to array method, or you can call functions, and append this array inside this image data. Then we need to reshape this image by these types 1, 256 by 3. Why? Because you can say image len of the image data. So len of the image data is nothing but the number of the images. Okay, so you can see image data. So this is the actual image data, and we need to reshape this. After reshaping this we need to divide this image by 255 to normalize our data. So you can see here I divide this image by 255. Then we are going to build our model. Okay, so you can use simple dance layer to actually build this autoencoder, but in this case I'm using convoluted because I'm dealing with the picture. So model equal to sequential, you can see a sequential model, and then I initialize the number of the kernel and the number of the filter 64, and the kernel is 3,3, and activation function we're going to use rel activation function, and the padding is same, no padding is included here, and input shape is 256 256, 3. Why 3? Because we are dealing with RGB image, color image. Then you can see a max pooling layer for a max pooling layer 2,2 kernel, and again 32, again 16 and 16, and you can see here after when we put the 16 we are going to upsampling it. Okay, if I comment out those lines, okay, these lines and also these lines, okay, just this line, okay, sorry for that, and run this code again, and okay, okay, it takes some time because you can see here the method and the functions are loading. So you can see here 256 256 64, that means 64 filters, okay, and it's divided this 1 to 8 1 to 8 by dividing by 2, 128 128 64 64 32 32. Okay, this time we have to this filter is right now 32 by 32 and there's 16. So now we need to upsampling it. That's mean 32 by 32, then 64, then 128 and 256. That's mean we need to reconstruct these images. So that's why we're going to upsampling these images. Okay, you can see upsampling 2 cross 2. That's mean the max pooling, that's mean we are dividing this. Okay, dividing this pixel 256 divided by 2 equal to 128, 128 divided by 2 equal to 64, and 64 divided by 2, that's mean 32. Now we are upsampling, that's mean we need to multiply by 2. So that's mean 32. So if I go here 32, that's means 64, then 128 and 256. That's mean it will reconstruct these images. I think it will make sense to you. Okay, that's mean 256 divided by 2 equal to 128, 128 divided by 2 equal to 64, and 64 divided by 2 equal to 32. Okay, this is the actual max pooling here. If I do upsampling, that's mean we are subtracting, or you can say multiplication, not a subtracting, multiply. So upsampling, then again upsampling, then again upsampling, then 3. Okay, I think it will make sense to you. Okay, so if I run that, okay, and you can see for the compilation you're going to use optimizer as Adam, and the loss you're going to use mean square error, and the matrix you're going to use accuracy matrix. Okay, if I run that code, shift enter, so you can see here 256 128 128 64 64 32 32, again 64. That's mean 32 cross 2 64, again 64 cross 2 128, 128 cross 2, that means 256, and finally you can see here 256 256 3. That's mean this image is right now reconstructed. Okay, so you give the input image and it will reconstruct the image. So if I do fitting this model, then predict this model and then show, if I see the images, okay, if I see this image for 1000 epoch, so let's see first only for 10 epoch. Okay, I think the image is not clear right now. Okay, yeah, you can see here image is okay visible, but not so clear than this Mona Lisa picture one, okay, but it will make sense that this picture might be the Mona Lisa look like. So if I increase the number of the epochs, so let's say 100, okay, and then you can see here the training is done, not done yet. Okay, might be my GPU is activated, might be. So you can see loss is 0.0018 and accuracy is nothing but 0.98. That's been 98% accuracy on the sketch. So you can see here it will take some time to actually train this model. So if you change the number of the epochs, so it will give you the more perfect, okay, more perfect result. Okay, so you can see here 100 maybe will take some time. Okay, so you can see here this image is right now so more visible. Okay, before the 10 epoch, after the 10 epoch, after that, not 10 actually 100 epochs. So you can see here the image is right now more clear than before. Okay, so if I change the number of epochs, and this image is looks like so clean. Okay, so let's try it for the 2000 epochs. Okay, 2000 epochs, and I'll pause the video. Okay, I will back how and the trend is done. I think it will take 5 to 10 minutes to actually train this model. I don't know how it takes some time because it's 2000. So finally, you can see here our model training is done for 2000 epochs. So right now you can see here this image is much more clear than before. Okay, so if I go up, you can see here when I feed the actual images, you can see here independent and the dependent feature both are same, because in autoencoder I already talked about that the independent and the dependent feature must be same. So image final and the image final both are same. Okay, so then you can see here, so don't worry on that, I will put this code on my GitHub and as a and also in my description, so you can also grab this code. Okay, so you can see here for 2000 epochs the image is much more clear. So in upcoming tutorial I will try to make the videos regarding the noise reductions and image colorizations using autoencoder and some basic technique to actually color in the images. I will be discussing on the next topics. So this is the tutorial. Hope you will enjoy this tutorial, and make sure to subscribe my channel and must hit the bell icon for new update.